Okay, so if you didn't see the last video, I actually just did number 6 in the video above. So if you have any questions on number 6, you'll just pop up to the video that is posted above. So I'm going to start with number 7, and I love this problem. You can see the heart around it. I don't do that often, but I do love this problem because it gives a lot of depth and understanding of percentiles. So it says here that we have a dot plot of baseball players' salaries. And Brad Lidge played a crucial role on the Phillies closer, pitching the end of many games throughout the season. His salary was $6.35 million. So that was his salary. We need to find what percentile he was in relationship to the team. So the first thing I'm going to do is I'm going to go up to the dot plot and figure out where he is. So this is 6. This would be a straight 6. This must be him right here, 6.35. 7 would be right in the middle. So this must be that $6.35 million right there. So this right here is Brad's salary. So to figure out what percentile he's in, what I would have to do is figure out how many people made as much as him, which it doesn't look like anybody else did, but as much or lower. So I had to count how many dots there were. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So you'll notice that I have 23, and then I had to figure out, well, how many were on the team. So 23 out of 24, 25, 26, 27, 28, 29. He actually was at a high percentile. There weren't many people making more than him. So 23 divided by 29, it places him at the 79th percentile. So his salary was as high as or higher than, 79% of players on his team. In B, it says find the z-score. Find the z-score corresponding to his salary. Well, the way I would need to do that, I would take his salary and subtract the mean. If you look right here, your mean is right there. So it's really small. You would have to have the mean because I need to figure out the distance from the mean, and then I'm going to have to divide it by the standard deviation. If you look, that is all right here, mean, standard deviation. So I'm going to take the distance that he is from the mean, so that 6.35 million, subtract out my 3,388,617, and then divide by my standard deviation. So you can see my math here for that, and I get 0.79. And this is why I love this problem so much. It shows you, without me teaching yet, it shows that when we did the percentile here, it actually corresponds to the same percentile with the z-score. We're going to get this lovely table in the next lesson that would show you that. On here, we're going to be calculating percentiles, and you're going to see that z-scores relate to percentiles. So this is kind of the foreshadowing of that connection. Okay. In number 8, we're actually going to refer back to this same problem. So for that one, it says, did Ryan Madison, who was paid for $1.4 million, have a high or low salary compared to the rest of his team? Justify your answer. So I had to figure out where 1.4 was again. So I looked here. It looks like this right here is, well, this would be 1 right here. So he must be one of these 2 dots. Okay, oh, whoops, I'm sorry, 1. 1.4 would be one of these dots right here. My guess is that it would be closer to this one. So I used that one and counted how many were at or below his. Well, that's one way to do it. The other way to do it is to, and he would be below the mean in that case. The other way to do it is to actually use a z-score. So it looks like actually in my work, I decided to use the z-score. So I went through and I took his 1.4, I subtracted the mean and divided by the standard deviation, just like I did in the last problem, to figure out that he is actually a negative z-score. He's lower than the mean. So his salary is 0.53 standard deviations lower than the mean. So when they were asking, does he make about the average or less than, he makes less than the average. I also did the math for, he was the 14th value out of 29, which would put him at about the 48th percentile. So either way that you did the math, he should have been below average when you answered that question. Okay, two more problems. Number 9 is the same problem that I had, or similar, I should say, to the problem that I had that we worked on in groups yesterday. It's the idea of where would these curves, like where do the mean and median fall? In the first one, the mean and the median would both be at A, and the mode, actually, if we were throwing mode in here. In a symmetric distribution, they're equal to each other. In a skewed distribution, it would actually be C would be the mode that you saw on there, B would be the median, and A, because it's a skewed to the left, A would be pulled to the lower values, which means that A would be lower. And in the last problem that we have here, we have this dot plot, and it asks you how to describe it or cuss. So that's just a review problem from what we've done before. My center was at about 15 minutes. The way that I did that is I counted up that there were 50 values here. It took me a while, but I realized there were 50 values. So I counted into the 25th value, and it ended up being in the 15-minute range, which was right here. It was like right in here. That was the 25th value. So I use the median for this. I use the median for this because it's a skewed distribution. We want to use median. So I literally found the middle value, which was right in here. My unusual features, I'm noting 2 of them. I believe that this one, and I did not do an outlier test for it, but I would believe that 80 and this 90 minutes to commute, those 2 would be my outliers. My shape is definitely skewed to the right because of these being, it would pull the mean to the right. And my spread is from 0 minutes to commute, they must work from home, all the way to that 90 minutes. And that is all for the homework.